Hello Sixes. So I saw some of you guys work already from this morning and it looks really good, the people that submitted. So based on that, we're taking next steps. Our next steps, as I noted this morning, are going to be about comparing data sets. So now we've looked at single data sets and how we can represent them. We want to know if we have multiple data sets, how do we compare those? Like for example, here I have sets of exam scores from two separate classes of students. And if I were given these exam scores, like if students, I don't know, produce these results, the question immediately comes out like, which class did better? Well, it's really, really difficult to see when you're looking at lists of scores like that. If we visualize the data, it gets better. And we've seen two visualizations. I chose dot plots. I think they work better in this context. So I've made dot plots of each of these situations. And then based on these dot plots, our question is, which class did better? Well, it's kind of hard to eyeball. When I look at these, they're really similar. This looks like it's more kind of spread out on the low end. So it looks like this class probably did better, but then like how much better? How can I describe these things? That's difficult questions unless you have strategies to go about it. So we're looking at which class did better. What are some ways we could answer that question? One of the ways that's common is to measure the center of the data. So we have measures of center. We're just looking for the center, the middle of the data, and that's it. The three common ways that we need to talk about this year, the three measures of center are mean, median, and mode. And there are lots of videos online talking about these. If you have trouble, let me know and I'll get you supports. Mean is the average, the way you've been taught to average things, where you add up all of the data, add all the stuff together, and divide by the number of data points. So when I look back here, like I would add all of these numbers together and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. So I'll divide by 11. So that would be the mean. It's the average, the normal way you've been taught to do it. The median is the data point at the center. So you put all the data in order and you just find the one that's in the middle. So, okay, the mean, we actually find an average. The median, you just find the middle value and that's it. The mode, you just find the most common value. The mode is kind of the least useful of these three, but there are times when the mode makes the most sense. So let's look at examples of all three. I'm just going to go with my same example we've been doing here. Here's my class that we have, and if I'm looking for a mean of how this class is done, I want to take all of these scores, and they've got 90 plus 87 plus 85, 82, 81, 80, 78 plus 74 plus 70, 65, and 64. Ah, so close on my spacing there. I'm just gonna copy this because I'm lazy. Tells us 856. So this is 856 divided by, I just said n here, and this is the normal letter to use for this, but this means the number of data points. So when I look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got 11 data points. This will be divided by 11. And let's go ahead and find out what is the mean of that data. Instead of that, I want 856 divided by 11. I get, let's round it off to 77.8. That is 77.8. So on average, the average score, the most middling score in this class would have been 77.8, which makes sense when you look at this. Like, it's saying that these scores trend lower than these scores do, and that's why there's 5 data points above. So that's the middle of class 1. So class 2, just do the exact same thing. Go ahead, pause the video and try it, and then play the video, and I'll show you what's up. So I'm assuming you pause the video and average these. It should be 90, 87, come on, 84, 78, 78, 75, 72, 69, 65, 64, and 60, and that is 65. Good. All Control, copy, add those. We get 822, and when we divide by 11, it'll be 74.7. So 822, and then we divide it by 11, because I think this should have the same number of data points as above. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I forgot what the average was. 74.7-ish, real close to that. Good. So mean is by far the most work, but it also is the most real, like the actual center of the data. And you can see class 1 did significantly better than class 2, like about 3 points better. 3 percentage points is half a grade. That's a lot. Good. So the mean is usually the most work and the most true, like the actual center of the data. Let's look at other centers. Median, we just want to find the middle data value. So I'm going to start on the outside and just cross off data values. I've already put these in order, or else we would have to do that first. And you can see the median here is 80. We're going to hit the exact same type of thing. Just to make a point, if this class had that, let's say I've changed the data and this is the data now. Well, I'd go about doing the same thing, cross these out and work towards the middle. And then I would get there. So I actually have to do the average of 78 and 75. So the median up here is just 80. The median down here is 78 plus 75 divided by 2, and I can tell that's going to be 76.5. So again, class 1 outperformed class 2 significantly, this time about 3.5 points by a different measure. But notice, class 1 did better by 3.5 points. By the nature of the data, the medians are higher than the means. Like this is 80 and this was what, 74, 76.5. So both of the medians are higher just by the nature of this data set. The mode is the most common data point. When I look through these, there's only one of each data point, which means this data set has no mode. This data set down here, if I look through, there's one of each of these. Oh, there are two 78s. That's more common than all the rest. So the mode here is 78. I wanted to make a point that there's another possibility. I've just changed this 65 to a 64. So when I look through, I have 2 of those and 2 of those. In that case, we also have no mode. So exactly one last thing we need to talk about. Those were our 3 measures of center, and you'll have to use them today. The last thing is, there's another way that these sets are different when I look at them. What I'm thinking of when I mean another way, this one starts at 90, and it covers like that space. Well, this data, just in general, is more spread out. Or like if I look at the center of this data, we have like some clustering going on here. If I look at the center of this data, things are just not quite as clustered. They're more spread out. So we need a way to measure the spread of the data. So we have measures of spread. There's exactly one you have to know about. The range is the distance between the highest and lowest value. So for this one, I'd be looking, the range is, well, the highest value is 90 and the lowest value is 64. And so the difference between those things is 26. And that's our range given that data. This one will be similar. Highest value is 90, lowest value is 60. So the range there is 30. Whoops. And it just shows you that this data is more clustered to the center and this data is more spread out, just a little bit. And you can see that when you look at the data. This is just a little more spread out than this is. Those are all the new things I have for today. So let's go ahead and look at your assignment. We're going to give you some dot plots in a context of running per week. We haven't talked about shape of data, but we're going to soon, and you can go ahead and answer this. These have very different shapes, these data. So tell me about it. Compare the center. Well, center, if we just say center, use the mean. Calculate the median, great. The range, you know that. What do the median and range tell you about the data? Well, answer that. Then we're rolling die. When you rolled it for a while, you got this, rolled it again, you got this, great. We're comparing those data sets, exact same things. Looking for mean, looking for the ranges and the difference between those ranges, and then looking at how the data is skewed or symmetric. This has to do with that shape of the data that we haven't talked about yet, but I think you guys can get through it. Yeah, good. That's all I had to say. Best of luck, sixes, and we will talk about it soon. Bye-bye.